So it's time to go into a more practical part after hearing so many theoretical things. And I promise you already this morning that we're going to have a deeper look into potential scenarios for aftermarket solutions. So last year we were showing outside demonstrations in two remote controlled cars outside our new car crashing, and the videos are still available. We will review on that. And today we're going to show you something new, which could be also potential use of the eCall value chain. We will start with this topic, automated emergency devices. We will make use of the infrastructure which will be deployed within Europe. Just one remark, we cannot send a valid vehicle identification number in such a device. So right now we are still in this task force discussing how we have to handle this, if we are allowed to handle this. Clear is definitely, if the call is manually activated, you can dial 112 like on a mobile phone. So in the worst case, the solution will be treated as a single, normal mobile phone. And that would be a pity, according to the PSAP suppliers, and also the police and firefighters in the countries, because they would like to get this positioning information. Very shortly, so where do we come from in this case? I just want to show. Well, the device itself is unfortunately not yet coming from Japan, also not coming from the US. So I had to talk to European suppliers, and this mountain is very famous. It's a nice mountain in Switzerland. And the company making these defibrillation devices, the name is Schiller AG. And as I came to them with this idea, they said this is brilliant. We would like to continue to work on this one. And exactly with this solution, that's where we are right now, we want to address this area. So the device itself is not related to a vehicle at all. In direct sense, it has nothing to do with the deployment of pan-European eCall in Europe. Indirectly, we're going to make use of the backbone. So not mounted to the car, not connected to a car, manual triggering, we can take the solution like we know it from vehicles. For, let's say, automatic triggering, we have to wait for advice from the insurance industry, and it's clear, if a device drops on the ground, it should not trigger an emergency call. This would definitely generate a false call. This is absolutely a no-go for the police and for the firefighters. These are people. So we have to still define this area, but we think we can identify and take something which we can get from the insurance industry. There will be no VIN in there. So we have to settle this issue as well. I already showed you the mountain. Now, what is this all looking like? Typical applications in an office or in public areas. Every public building in many of the countries in Europe needs devices that are able to, let's say, reanimate, defibrillate people. Or even on road use, or even policemen could have this when they walk around, patrol around, or even in big stadiums, wherever. Now you can already see, if you take such a device, the person, he will walk away from the location where he was. So he will go directly straight, let's say, to the place where the emergency took place to support the people there. So where the heck is that person gone? And that's now very interesting. We use, let's say, the specifications of eCall today, and European eCall. The PSAP could recall and pull the minimum set of data again and look at the actual position of this person. And there comes another aspect here. This device is already existing today. Devices like these, in that size, are already in the market, sold throughout, for example, Europe, and used to, let's say, reactivate people. I will show you in one of the next slides how this looks like. Just give you first an idea. The size is really not bigger than a pen. And what you also will need, definitely, that's also in those devices, are these kind of straps. You put these badges on the body, it's quite easy to be done. So until here, I think everybody can do it. But the biggest problem we have, if we see some of our valuable people lying on the ground, it could be father, mother, child, maybe even colleague we have a very close relationship with, we start to shake and to shiver. And exactly there is the point. So the nice thing about these devices is that they have a speaker there, and the speaker will give advice on what has to be done. Now, if we could manage to have a connection made to the PSAP, and at that time, we do not only get the possibility to send the exact position, but as well, at the same time, we have an expert sitting there that could help us through, let's say, the next maybe 5 minutes until the ambulance arrives. So this is a real serious case, and therefore we have also to approach it very seriously. What we did, in the first thing to show that this can work at all, we took the smallest eCall device available, we connected this remotely, let's say external, to this device, and we could demonstrate this. That's what we did last year. And then we said, okay, now we have to integrate this. And that's what we have done. And that's what we're more or less having here on the table right now. I have the device with me, and in a few seconds we're going to demonstrate this here live. So we see here a power on button, which will be pressed, then the device will switch on. And I did, let's say, for some reasons, glue or put a sticker over the speaker, because normally it's speaking very loud. And you guys here, coming from the APAC region, made the same experience like I did about 20 years ago, coming with a Siemens mobile phone, which I like to sell here. And the first question I got from Hong Kong is, can you increase the ringer loudness? Because on the road I don't hear the phone ringing, right? So in this case, also the loudness must be in such a, let's say, level that at least the person who is serving somebody, in that case, maybe on the road, can still hear the advice of the device. So the device will tell, please put these pads here and connect it to the device. It's the first thing that normally is going to happen. We are not going to do that. I could make a joke and ask if you would like to get rid of some of your colleagues and we could demonstrate live. But, so this is happening first. Then the device already will start to put the ECG here. Then you press this button, you press this button, and the button then will definitely scan the person. And the nice thing here is, this device can make the decision. You can reanimate this person, or you better not do it, because you will harm it more than the situation he's writing. But the nice thing is, we're activating the emergency call at the same time. The ambulance, more or less, via the PSAP, can be activated, can already be on the road, and the person sitting at the PSAP side can support us to stay calm, to just do what the device said, or even give additional device in case maybe this device may not be used. So what to do? Imagine we're in such a situation. Then if everything is fine with this check, this button will be released, and then the device can provide this shock to reanimate this person. If everything goes wrong, say very theoretically it's not empty, but would be empty or something like this, the device will tell you what to do instead. Yeah, so push 30 times and breathe 2 times and things like this. So what is in this device? We can see here. I already explained that the analysis is done within the device. We can activate that shock. There is various kinds of support that will help the person to use this device, not to be, let's say, in any problem situation, getting afraid or whatever. And here comes another additional thing. It is collecting 30 minutes of, let's say, the behavior of the patient. Now imagine ambulance comes there and you have this valuable information. I tell you what right now is going on in the ambulances. In the ambulances, this data is sent over the air by high speed to the hospital. And this device can do the same. So we are getting into an area which is very interesting for the medical industry to use something what is initially thought just to be used in cars. As said, this is fully compliant to what has been standardized within the eCall, but we cannot use the data identification number because this is not a car. It's very important. There will be changes in the medical industry. Medical to say this device is coming from Nihon Koden, or this is coming from Schiller AG, or whatever, and it's also telling what kind of device it is. It's not there today, and it's not to wait another 5 or 10 or 20 years. No. Technology is there, start to use it today, that's the point. I think we are now getting to that situation where we have to see if we can get the PSAP shown on the screen. Can we start the PSAP? I would like to see the PSAP here. So in order to get the demonstration running, we have to trick a little bit with the device. So we built in some delays, and I already told you we put some stickers on it, but we will definitely see what is going to happen. First we get the PSAP here. Brilliant. So this is the PSAP like we know it from last year demonstrations, and now I first start the device here. I first give you some feeling about what is ongoing. So what is the device saying? The device is saying, okay, please take this stuff and put it on the body of the person. Yeah. So the device is starting and providing this information. If these electrodes are not put there, it cannot go in the next step. So this will be repeated and repeated and repeated. So we have to see that we get a way of how to manage talking of the device and the PSAP, right? This is one of the things which is ongoing right now. And what now is getting interesting, just have to wait a few seconds. So now you see flashing button here, I press it. And now the nice thing is coming. We are sitting inside here, and I understood GPS is there. So the device must collect the position of the device where we are right now. And it has to, let's say, calculate this minimum set of data. Of course, we have no VIN. So we must also tell in the future that this is not a vehicle. And of course, there are possibilities. Because in the minimum set of data, there are identifications about this is a truck, or this is a passenger car, or even this is a motorbike. So in one of the definitions there, theoretically could be written, this is not a vehicle. So now the stuff is dialing, and we will see soon here, on the right side here, up there, that the minimum set of data is shot there. Here you see the data, here you see the PSAP, and you can go there. And then the PSAP will talk to us. Hello? Hello. Yeah, so that's more or less how it is functioning in this emergency. So you can see such a minimum set of data can provide additional help for the PSAP to direct the ambulance exactly to that place where the emergency took place. So this is, let's say, the momentum situation we have with the defibrillation device. Now you can think about all the other scenarios I was talking about. And of course, this will need some further integration, maybe modification, to send also the ECG data and other interesting things to the PSAPs. We have to discuss first with the PSAP what kind of data, in which detail, in which length we want. In the meantime, we will send the minimum set of data with the content of the position of the emergency. That's the status right now for, let's say, aftermarket devices when it's with respect to health, to alternative emergency devices. Now we have seen before this Genie device. And we already heard from Fujitsu 10 that these devices are getting smaller and smaller and smaller. You have seen the picture so far only. I would like to ask Michael to come on the stage and just to show you his device. You can see how small such a device can be.
So my colleague has told you a little bit about the Genie. He's told you it's a discrete device. I think it's pretty discrete. It's very small, very thin. I think it looks fairly stylish. I think a lot of people would like to have this in their car. It looks good, and it performs a very important function. So, eCall itself, the technology behind it, yeah, that's quite complicated. But for the user, it's quite simple. We press the button, and then we hope for a dial. We can see that we're already talking to the PSAP. We've just sent our minimum set of data. The PSAP knows where we are, and we already have a voice link with a very efficient operator over here. But very importantly, the minimum set of data is, enable emergency vehicles to find us very quickly. That's all there is to demonstrate, because in use, it is very, very simple.
So have you seen how quick this went? Imagine it's your child, your wife, your daughter, whatever, sitting in that car, and this device is retrofitted in the vehicle. Of course, it must be fixed somehow. Not necessarily to have any information from the car. The crash sensors inside can detect this is severe, or, like he has done, just manually activate it. You have seen in seconds it was connecting to the PSAP. It's really optimized, and this is something similar like the people in Romania are testing today, or in the other 9 countries in Europe, or the other 6 countries that are testing right now. So we see technology is there, and most interesting here, again, you have seen these people are coming from the UK. The UK did not sign the MOU for rolling out the eCall, but the industry is ready. And that's a very, let's say, good achievement so far from the industry. And so far also to our demonstrations on the automated emergency devices